Okay, hello again. This is on video on I'm going to continue with chapter 6. And so let's get started. I hope you're doing well. So let me get it started. And I'm going to go directly to try to do problems. And so before I do problems, of course, I'm going to talk about graphing exponential functions. So I'm going to take this part and then move this up so we have enough room. So the way we talked about this last time, the way we define exponential functions is by creating two families of functions that have one family has base greater than 1 and the other family has base between 0 and 1, right? So we can graph these by using a table. So let's graph one of these. We're going to graph this example, f of x equals to 2 to x power. Okay? And we're going to graph one of this family, the other family here, and we're going to graph f of x equals to 1/2 to x power. So to graph, we put some numbers here for x, -2, -1, 0, 1, 2. And now we're going to find the function values. F at -2, do some scratch work here, would be 2 to -2, which is 1/2, right? I mean 1/2 to the second, which is 1/4. And then f of -1 will be, well, so the same thing would be -1 and would be 1/2 to first, which is 1/2. Now 2 to 0 is just 1, and 2 to 1 is 2, and 2 to the second is 4. So what we are going to do is this right here. We are going to graph a coordinates plane here, Cartesian coordinate plane. And to graph these ordered pairs, we need these numbers on the x-axis. So we need 1, 2, we need -1, -2. And then we need to go from 1 to 4. So 1 to 4. All right, so we know that -2, 1/4, this is -2, 1/4 is about right here. So that would be this point right there. -1, 1/2, -1, 1/2 is about a little bit higher than that. 0, 1 is right here. And then 1, 2, 1, 2 is right here. And 2, 4 is over here. Right? So it's growing exponentially like that, and over here it's going to 0. Now this line right here, which is in this case is just x-axis, is y equals to 0, and this is called the horizontal asymptote when x goes to -infinity, and this number is 1, of course. So when x goes to -infinity, 2 to -infinity is like 1/2 to +infinity, which is 0, right? That means when x goes to infinity, negative, f of x goes to 0. So you see it over here. As x goes to infinity, the function values go to 0. Also, the y-intercept of this graph is basically when you put 0 for x, 2 to 0 is 1, right? And when x goes to positive infinity, f of x also goes to positive infinity. So the good thing is that this graph actually looks like the graph of all the members of this. 10 to x, e to x, and e is a number I said we're going to talk about. And so any number greater than 1 is in the base is going to look like that. Now notice that if the number in the base is bigger, the bigger the number is, the sharper the increase is here. So for example, if this is 2 to x, 10 to x will be even sharper than this, right? That's what is going to happen. So the sharpness of it has to do with what? The sharpness going up has to do with the amount of this number. Of course, it has to be greater than 1. It can't be 1. And that's what we get. Okay, so that's the graph of 2 to x and all the members of this family. What about this family? Well, for this family, we can come up with a table as well. And so negative 1, 0, 1, 2, and then graph it. So what is f of negative 2? So f of negative 2 is like you put a negative 2 here. You want to know what this is? Well, there's a simple rule we can use that a over b to negative m is b over a to positive m. Now we can go from left to right or from right to left, either direction. So 1/2 to negative 2 is really 2 over 1 to positive 2, which is 4. And if we make this negative 1, right, we make this negative 1, that would be just what? That would be just 1, so this would be 2, right? Now 1/2 to the 0th power, of course, is just 1, and 1/2 to the first power is just 1/2, and 1/2 to the second power is 1/4, right? So 2. Okay, so if we were to graph this in the same coordinate plane, let me erase these. So we can use maybe a red pen. So for negative 2 goes to 4 here. So we start from here. And then negative 1 goes to 2, which is about right there. 0 still goes to 1. 1 goes to 1/2, maybe a little bit higher there. And 2 goes to 1/4. So as you see, is a decreasing function, and we call that exponential. It still is exponential, but it's exponential decay. This is exponential growth, this is exponential decay. It's like you start with like 100 and keep multiplying by 2. Of course, that's exponential what? Growth. Now if you keep multiplying by 1/2, then you get exponential decay, and so forth, right? So that's the idea. Now, we see that the sharper the decrease, then the smaller this number inside the base. So if this is 0 and this is 1, if the base is greater than 1, the bigger it is, the further it is from 1 on the right, the sharper the increase is going to be, right? And if the number is between 0 and 1, the closer the number is to 0, the sharper the decrease is going to be, right? So the sharpest one is the one with the smallest number in the base. All right, now for the red one, for the red graph, we could have graphed it without a table. You know how? Here's how we could have graphed it without the table. We know that 1/2 2x can be written as, according to what I just described here, right? We go from right to left. So if the power is positive, we can make it negative. So I can make the power negative if I flip the fraction. This is just 2 to negative x. And you compare this to what we have here, and you see that that's just transformation, reflection over the y-axis, right? So if we reflect this blue one over the y-axis, that means just change x to negative x, we get the graph of the red one. So we didn't really have to make the table. All right, and for the red one, as x goes to infinity, then f of x goes to 0. And when x goes to negative infinity for the red graph, f of x actually goes to positive infinity. And the reason, of course, you know, is right here. Because if you put infinity here, right, negative infinity here, negative times negative would be positive. So 2 to infinity, it goes to infinity. And if you put positive infinity here, 2 to negative infinity would be, of course, 1 over 2 to infinity, which is going to 0. All right, now that we know about graphing these things, let us do some problems, right? So let's do some problems here. So it says here, the graph of 3 to x is reflected about the y-axis and is stretched vertically by a factor of 4. What's the equation of it? Now, we talked about this before, that if you have a function, let's say we have 3 to x, right? Now we know 3 to x looks like what? Looks like this. We just talked about these shapes, right? Now, a problem is the transformations. How do we deal with transformations? Well, we already know about transformations. If there's a point on this, a and f of a, and I discussed this in previous videos, how it changes depends on the transformations. For example, if I give you what we have here, the graph of this is reflected about the x, let me erase this so you can see it. So we have the graph of 3 to x is reflected about the y-axis and is stretched vertically by a factor of 4. So reflected about the y-axis, reflection about the y-axis means you change x to negative x, right? So that means basically you have to multiply a by, x by negative, right? So you end up with 3 to negative x, right? So that's the reflection. That's the reflection about the y-axis. Stretch vertically by a factor of 4. Stretch vertically means what? Multiply by 4. So that is the new function. Let's call this f of x. We could call this g of x because we don't want to call them the same thing, okay? So basically what happens to the points according to these transformations? You multiply x by a negative and multiply y by 4. So this way you can transform all the points in the original parent function, maybe a few important points, and then graph this by transformations. All right? So that is number 3. So in number 4, it says again reflected. So how do we write the equation for this one? Reflected about the y-axis and compressed vertically by a factor of 1/5. So that means the new function, let's call it g of x, is going to be 1/2 To what power? Well, the power is negative x already, so if you multiply it by negative, we get positive x. So that would be reflection about the y-axis. If it's positive, you make it negative, you reflect it. If it's negative, you make it positive, that's the reflection. So you just have to multiply by negative, whatever that is, the answer goes here. And compress vertically by a factor of 1/5. So there. Okay? All right. Now, let's do one more. What about this one here? Well, it says shifted right 3 units, shifted right 3 units, stretched vertically by a factor of 2, reflected about the x-axis, and then shifted down 3 units, right? So let's write down the x and the y transformations. So here, shifted right 3 units means, what do we have to do? We have to go to right 3 units, right? So that's the x transformation. Stretch vertically by a factor of 2, right? Stretch vertically by a factor of 2 means we have to multiply the right hand side by 2, right? Multiply by 2. Reflected about the x-axis. Now, reflection about the x-axis happens if you change y to negative y, or negative y to y, right? So that means we have to multiply by negative on the right hand side, right? About the x-axis, and then shift it downward 3 units. Shifted downward 3 units means you subtract 3 from right hand side. Now again, remember when we talked about transformations, we have to do transformations in each variable independently. So it doesn't matter in what order we do them this way, but we have to do these transformations in this order, right? So let's do this one first, and then we do these in this order. So first, we're going to do this transformation, which is moving to the right 3 units. Now, so we have to call this something else. Let's call it g of x. So g of x would be 1.68 to the power of x minus 3, because it has to go to the right, so in the equation we have to put minus. And then multiply by 2. Okay, I multiplied the right hand side by 2. Then multiply by negative. I did. And then subtract 3. There. So that would be the new function, right? All right, so that's number 6. Let's do a few more of these. Let's do number 8. It says, for the following, graph the function and its reflection about the y-axis in the same axis. Okay? So, to graph this, we are going to look at the parent function, which is basically 1/2 to x power. That's the parent function. And what does it look like? Well, it's a decreasing function, right? And goes through 0, 1 here, right? Now, remember y equals to 0 is the horizontal asymptote, right? So what happens to the horizontal asymptote? Well, the horizontal asymptote, it has to go through this transformation, and this transformation is nothing but what? So if we have, let's call this g of x, because we have f of x here. So if we have a and g of a on this original graph, what happens to it under this transformation? Well, this is only one transformation, is multiply the g of a, the right hand side, by 3. So this goes to just a and what? 3 g of a. So every point on here That's how you can transfer it into this graph. So 0, 1 goes to 0, 3, right? So that's 1, 2, 3. So that's 0, 1. And then horizontal asymptote, 0 times 3 is still 0, so it doesn't go anywhere. Horizontal asymptote stays here. So this graph is going to basically look like this, right? There. Now, we were also told to graph the function and its reflections about the y-axis in the same axis. So reflection of this about the y-axis would be, let's do it with the red pen. So it's going to look like this. And you know the formula for that reflection, right? Because if you reflect it about the y-axis, you just have to change that x to negative x, and if you do that, this becomes just 3, 2, 2x, right? So the red one is 3, 2, 2x, right? You didn't have to find the equation for it, you just had to graph it, what we did. All right, so let's do a few more of these. What about number 12? Now, so number 12, we have to graph these. This would be easy to graph because what we have here, let me get the graph too, it's not really that hard. So what we have here is the same parent function, 3 to x. Here is vertical stretch by a factor of 4, vertical stretch by a factor of 2, vertical shrink by a factor of 1/4. So that's all there is to it. So the only difference is that between them, this is the original graph, which goes through 1 here. So it will look like the same graph, except it goes through 4 instead of 1. So that one right there is the graph of that. And the rest of it remains the same. The horizontal asymptote is the same, doesn't change for all three. This number goes to 2. So this graph here is the graph of that one. And 1/4, it actually goes to 1/4 instead of 1, which is this one right here, right? So those are the graphs of those functions. Now, let's do, okay, now this one, we have to maybe get this and keep it on the side, make it a little bit smaller. All right, that's good enough. So what we want to do with this one is we want to find out which one of these functions is which one of these graphs. So what we have to do is write down these functions. So we got f of x equals to 2.69 to x power. And then we have another one, which is 2 times 1.28 to x power. And then we have 2 times 0.81 to x power. And what else we have? We have 4 times, so we have f of x is 4 times 1.28 to x. And we have, well, not here, here. We have 2 more. Let me write them here. And we have 2 times 1.59 to x. and then last one is 4 times 0.69 to x. Now, which one is which? Well, let's look at it. So what we have here is that we have 3 of these that are exponential growing, exponential growth, and we have 3 of these that are exponential decay, right? Now, so this one, let's say this one, and this one are decay, right? Because the number inside is less than 1, right? See that one and that one. Now, if you look at these two, this one and this one, these two looks like they basically, the sharpness of the red one and the green one is basically the same, except that green one is higher than the red one, right? So that means is either this one, or that one, but these two have the same sharpness, except one of them is when x is 0, y is 4. The other one, when x is 0, y is 2. So the green one, this one that y is 4 is C. So we're going to pick C here for that one. And then this one, the red one that it goes through 2, B, is that one. And obviously the third one here is that A, which goes down sharper than the other two. So that one is A right here. Okay, we do the same thing with that, with the ones that are going up, right? It looks like that this looks like that this E right here and that D, right? They're kind of the same shape, except if you move this up, you get D. If you move it up at this point, if you move it up, you get D. You see, they're kind of the same shape. So D and E looks like they have the same shape, but this F1 is not as sharp, right? So we have 2 of these that are the same kind of number inside here, 1.28, but this one is 1.59, right? So we have to pick the ones that they're kind of the same shape, kind of looks like is D and F that have the same shape actually, right? D and F, kind of the same shape. If you move it up, it looks like that. And it looks like this E is going up sharper. You see, it's over here is going up a little bit sharper. So, so these two, this one and this one, they both have what? This one and the sharper one, they both have y intercept of 2. So the E is going to be the sharper one, and the F is going to be that right there. So we are left with only one of these, which is D, right here, and that's D. Okay, so that's just the practice of figuring out what graph is what based on the rate of growth. Okay, so let's do a few more of these. Let's do 26. It says for the following, give the horizontal asymptote the domain and range for this. So, okay. So it's 2 to negative x, so the transformation is just what? Here is 2 to x, right? So what does this transformation do? It reflects it over the y-axis, right? So basically what we have is this. Now, the horizontal asymptote doesn't change, it's still y equals to 0, right? Now, domain is all real numbers, right? You see, domain is all real numbers. The range cannot be 0, but anything above 0, right? Some students write 1 and above. That's not right, because these y values are less than 1, right? So the range is 1 to infinity, but 1 is not, 0 to infinity, but 0 is not included, right? So don't put 1 to infinity. What about all these numbers here, right? Okay, so that range, domain, and the equation of the horizontal asymptote. Okay, so that was 26. Let's do a few more of these. Number 32, it says, for the following, start with a graph of 4 to x, then write a function that results from the given transformations, okay? All right, so let's do that. So what is the transformations? So let's start with, so let's get the graph. Let me get this function, get this out of the way. So that's the function. So we're going to write the different transformations right below it here. So what do we need? Well, first one, it says f of x 4 units upwards. So 4 units upwards, which give us, let's say, g of x. 4 units upwards means 4 to x plus 4, right? So that's that one. Now, 33 says 3 units downwards. Well, that's easy. That's just what? 4 to x and then minus 3, right? And the next one here says, oops. The next one here says, the next one says 2 units left. So g of x is going to be 2 units left. That means we have to what? Add 2 to x, right? All right, so I'm doing these separately, right? And what about 5 units right? Well, 5 units right would be x minus 5, right? And reflect about the x-axis. Now remember, x-axis is here, so you have to change y to negative y. So we got g of x equals to negative 4 to x power. That would reflect it over the x-axis, right? And the next one says reflect about the y-axis. So reflection about the y-axis will be 4 to negative x. We make x negative. And the last one is reflect about, well, we did that already. Okay, so that's the idea. And let's do maybe one more. So for the following, evaluate the exponential function for indicated value of x. So what we want to do is we want to get rid of that. So we want to evaluate that at 6. We have several ways to do that. First, we are going to use just arithmetic by hand. So g of 6 means 1/3 7 to the power of 6 minus 2, right? So that's 1/3 7 to the power of 4, right? Now, so 1/3 of 7 to the power of 4, and we can use a calculator to do this. So it's going to be, let's see. So first way of doing it is 1/3 and then multiply by 7 to the 4th power. And that is, you can convert it to fraction by going to math, enter, enter. So it would be 2401 over 3. So that is g at 6. Now we could also go put the function in y equals 2, right? So we could just put 1 over 3, go to y equals 2 right here, right? Y equals 2. And then 1/3, 7 to the power of, put parentheses, x minus 2, right? So that's y1. So we can get out of here, go to home screen and clean it up. Then we can go to variables right here, and then go to y variables, then go to function, and the first one says y1. Pick that one. So that is our function g of x. Then we put parentheses 6, like that. And we get the same answer, and you can convert it to fraction again to get the answer. Okay, so that's this section, 6.2. I don't have anything else to tell you about this section. So what I'm going to do, I'm going to make a video on 6.3 and 4 together. I'm going to end this video here so it won't be too long, okay? So I'm going to come back here and say again bye to you, and take care of yourself and others, and see you in the next video.